allow me to sort of paint a few tangents for that.
Yeah.
So the first one is transcranial magnetic stimulation.
Yeah.
Right? I had a friend who did that to me. He gave me a weight blanket, put some TCMS stuff, activated it, and I knocked out for like an hour. I have like just within seconds, I was gone. I don't know what he did or where he got that from. And I wonder if we can then instantiate dream states by choice.
It's very interesting. So technology is going to be big in this realm. Like, what can we do? How can we activate dreams or activate them in a certain way? And I think TMS will be a big player in this, because you can literally manipulate the cortex. So these magnetic pulses can activate or deactivate parts of the brain. So in fact, if you can create virtual lesions, so you can become temporarily blind while you're awake, or you can become, if you hit the speech part of the brain, you cannot speech, or the math part of the brain, the angular gyrus here, you have a structure here, you hit it with the TMS and you can no longer do math. In fact, if I hit a part of the brain that has to do with construct like spatial imagery, mainly in the left temporal parietal region, it has to do with spatial imagery. If I hit that part of the brain with the TMS machine, I cannot do any kind of spatial imagery task. Like if I put
Rubik's Cube,
for example, or if I put splotches on a screen of like different splotches, I ask them to count. How many do you see? I cannot count them. But if I give you the same if I stimulate that part of the brain instead of creating a lesion, I stimulate it by hyperactivating it. You become like Rain Man. The Rain Man is you seen the movie Rain Man?
I have a concept.
I'll tell you what it is. So this is like
a savant.
A savant might be a guy, you take a chickpeas and you throw chickpeas, and there's like 200 of them, 234 of them, and he sees that for a fraction of a second. He'll tell you these are 334 by just visually scanning the table and seeing the chickpeas.
So you can actually hyperactivate, that is a result you get?
That experiment has been done, right?
Whoa.
So if you hyperactivate that part of the brain, and I show you 234 splashes, and I tell you how many do you see, you become temporarily a genius, and you will get very, very accurate answers by doing that.
For real?
For real, yes. So
does that lend itself to the idea that we only use 10% of our brain? That kind of sort of mythos that existed?
There's something about, so the whole 10% exactly doesn't the percentage is off.
Yeah, right.
But we definitely have untapped potential. Meaning,
very interesting.
So for example, in the parietal lobes, involved in spatial spatial imagery, and also things like artistic abilities. Right. So if you have a stroke to that part of the brain, or you have damage to that, if you have it in the left side, in fact, what occurs is that the brain is always in a constant state of battle. It's always inhibiting. There's a lot of cross inhibition going on, meaning the left hemisphere is always competing with the right. The right hemisphere is more emotional, it's more artistic, it's more big picture. The left is more mathematical, it's more logical. I know this sounds like pop psychology, but it's actually there's truth.
It's proof. Is this Ian McGilchrist, no?
Yes.
That's his research.
McGilchrist.
Yes, right.
So it's more logical. There's language in the left side of the brain.
Right.
Now, if I have damage, a stroke to the left hemisphere, what occurs in some people is that the right hemisphere become disinhibited. Okay, so the left hemisphere can no longer bully and suppress the right hemisphere. And in some people, you will see artistic talent. So they become like Da Vinci and Michelangelo, and they're maybe 10 years old. And this has been shown. So there's these people, neurological patients, they have the stroke in the left hemisphere, the right hemisphere, the arts modules in the brain. I'm being a little frivolous. It's like the inferior parietal lobules, the same parts that are active during dreams. Okay. They start growing. Literally, the neurons might grow. They might hypertrophy. This hasn't been shown, but the results are clear. We see that they get savant-like abilities by simply having a damage to the left side.
But they could also get mania in that case, no?
They could.
Yeah.
Also, if the damage hits the right, the right side of the brain, you might get math savants. So the person is 43. He's not really good at math or anything like that. He gets damage to the right hemisphere. Now the left hemisphere becomes disinhibited from it. It's no longer suppressed by the right and all the right hemisphere's restrictions, and the person becomes brilliant at math overnight. So this we know.
We probably also have some recorded cases of traumatic brain injury from playing football, etc., that leading into savant syndrome, right? Like that probably happens because you get hit here and then suddenly you can do fucking pianos and violins again, right? Like that kind of shit. But I'm also sure it's not as simplistic, because if I inhibit the right side, I can probably risk a lot of depression, and if I do it the opposite way, I can risk mania.
It's a great question. So now we're getting into the frontal lobes again. So the left frontal lobe is involved, the prefrontal lobe in the left side is involved in positive affect, positive emotion.
Right.
The right is involved in negative emotion. We know
Right.
this from neurology stemming back 50 years ago, maybe 30, 40 years ago. So you had neurological patients, they had damage to the left prefrontal, actually the DLPFC. There's damage to the left hemisphere, okay? So the right hemisphere is getting all the attentional resources, and the person becomes depressed, they become sad, you tell them they cry for no reason. On the flip side, if the damage hits the right, okay, the left hemisphere, which is involved in positive emotion, become hyperactive. It dances with activity, and because it has all these circuits going to the emotional dopamine centers, you become manic.
Yeah.
These guys will,
Fears of grandiosity, I'm God, that kind of stuff.
all that stuff, and that has to do with the left hemisphere. So we know that. Now you can use TMS to temporarily, if the person is manic, you might stimulate,
Suppress, right.
inhibit the left, right? Or the person. This is actually how we treat depression in these days. Is that if the person is depressed, you hyperactivate the left, you revive it by stimulating it. So this is well known.
So if people do not know, by the way, how TCMS and TCDS, there's
TCSS,
two,
yeah.
right.
Yeah.
There's generally a helmet or headphones, and headphones is a form factor that probably does not do the stimulation as well as the helmet does. And then there are electrodes too sometimes, but there's non-invasive methods that have come about. There's a lot of research on the entrepreneurial side. There's like a lot of companies trying to build out products with which you can do TCS at home. There's some angles about how you can learn faster wearing helmets and playing basketball as well that I've heard of. So this is a promising area of research, huh? Would you say?
It's quite promising, and some of the research I've been involved in the last couple of years is that TMS usually takes 6 weeks. So if you have a person with depression, in about 90% of cases, you can help him by simply by stimulating his left side of his brain. But he has to come every day to the clinic for about 6 weeks. 6 weeks. It's a lot. It's a lot. But now what's changing is that what we're doing is my colleagues, they are basically using the same therapy, but putting it all in one day. So you do all the stimulation in one day and you get the same effect. So in one day, you can treat 20, 30 years of depression. And often what you can do is you give them a drug, a particular kind of drug that makes the brain more plastic. There's certain drugs that would drive up
Neuroplasticity.
Neuroplasticity. So the brain generally is not, the brain can change. We know this until you die. And there are certain parameters for the brain that helps it become more plastic. As you age, you become the brain is less plastic. There are certain proteins called BDNF, GDNF, brain-derived neurotrophic factors. These are just fancy names for proteins that makes the brain more likely to grow new synapses and make new connections. When you are depressed, you need new connections because the brain is locked in a negative algorithm, right? A difficult negative loop. Right. So you go, I'm a loser. I'm this. I'm that. I will never, be a good, friend. I will never be this or that. So you have all these loops, circuits that are solidified.
Right.
By doing TMS and then making the brain more plastic by taking these drugs that can ramp up plasticity,
right,
you end up with a way to treat depression, for example, in a 1 day, 2 days, for example. It's quite fascinating.
Yeah, I actually had a friend who did a lot of this. It's the same guy who then actually had TCS use on me, but he was using it for his depression treatment, and he got into some clinics for that. And it was very interesting watching him come back happier every day. Because I had known him many years at that point and I never saw him happy.